It's one of Saturn's many moons. It's about 500 kilometers across. That's less than half the width of our moon. But in terms of geologic activity, Enceladus is a real firecracker. It's the most geologically active body in the solar system outside of Earth. Just look at it. Plumes of water vapor erupt from its south pole, reaching 300 meters high, and that's just what we can see. There's also an unseen plume that reaches 10 kilometers up through Enceladus's crust. You may be wondering how a tiny icy rock like Enceladus can release so much heat. Well, scientists have an explanation, but they don't think it's the whole story. So here's the thing. As it orbits Saturn, Enceladus is squeezed and stretched by the planet's gravity. This tidal flexing heats up the inside of the moon, and that's called tidal heating. Other moons of Saturn are also heated this way, but none of them are nearly as active as Enceladus. The heat from those other moons radiates out of their insides and cools off pretty quickly. But that's not what happens on Enceladus. The heat from its interior doesn't make it all that much warmer than the rest of the moon. Instead, it seems to disappear, and to solve this mystery, let's start with a little bit of context. The reason why Enceladus is geologically active at all is because there's a giant ocean of liquid water beneath its frozen crust. We know this because back in 2018, NASA's Cassini spacecraft plunged into the atmosphere of Saturn and dropped a probe called a gravity, a probe that detected a sudden increase in gravity as it passed through the ocean. Scientists estimate that the ocean is about 6 kilometers deep and contains 2/3 of all the water in the entire solar system, which makes it pretty easy for Enceladus to be the most watery world that we know of. But while we knew that there was an ocean under Enceladus's crust, we didn't know what it was doing down there until Cassini provided some very important clues. In 2015, Cassini observed that the icy surface of Enceladus was regularly blasted away by water vapor plumes. These plumes come from vents in the ice that reach down into the moon's subsurface ocean. Now, before we get into how these plumes are formed, let's take a moment to appreciate the fact that we were able to discover all of this. By studying a moon that is more than 400 million kilometers away from us, modern science is amazing. Okay, so when Cassini found out about the plumes, it also detected that the water vapor in them was moving away from Enceladus really fast. We're talking upwards of 200 meters per second. But for comparison, the escape velocity of Enceladus is just 23 meters per second. So the water vapor was literally blasting off into space. This means something was making it move super fast. And the leading hypothesis is that it had to do with the moon's orbit around Saturn. See, Enceladus orbits Saturn every 67 days, and it has an elliptical orbit, meaning sometimes it's closer to the planet, and sometimes it's farther away. When it's closer, the gravitational pull from Saturn is stronger. So the moon gets squeezed a little bit, and that squeezes the ocean too. Since the ocean can't move, the only place for the water to go is up, forcing it to turn into vapor and shoot into the air. And if the vapor makes it all the way to the top of the moon, it will blast off into space. That process is called sublimation. When Enceladus was first discovered by the Cassini spacecraft back in 1980, scientists thought that the vapor plumes might actually be made of ice crystals instead of vapor. It wasn't until almost 4 decades later that we were able to confirm that we were seeing actual plumes of vapor shooting into space. This discovery was made in 2018 when Cassini performed a daring plunge into Saturn's atmosphere and dropped a probe that could detect changes in gravity as it fell. As the probe approached Enceladus, it detected a sudden drop in gravity. This meant that something was missing from the vicinity, something with a lot of mass. And since the probe was equipped with a camera, it was able to identify exactly what was missing. The camera detected a big cloud of vapor surrounding the moon, which implied that a lot of water was indeed being blasted into space. But this raises another question. Why does the water stop coming out once it reaches the surface? You'd think that it would keep going up forever, right? Well, not quite. The strength of the gravitational pull from Saturn varies depending on how far away it is. Sometimes it's stronger, sometimes it's weaker. So as Enceladus swings closer and closer to Saturn, the gravitational pull starts to get stronger and stronger. Eventually, the pull becomes so strong that it overwhelms the power of the ocean. At this point, the ocean can't push any more water vapor up through the vents. Instead, the water vapor that's already in the air gets pushed back down into the ocean. So the plumes stop coming out until Enceladus reaches its farthest point away from Saturn. Then the whole cycle starts over again. Okay, so this tidal flexing does explain why the plumes come and go. But it doesn't really explain why the ocean is still liquid in the first place. I mean, the ocean is about 30 kilometers below the surface of Enceladus. And we know that the surface of the moon is very cold because we've seen frost on it. So, how can the ocean be warm enough to be liquid? To answer that question, scientists took a closer look at the composition of the vapor plumes, and what they found really surprised them. The water vapor was full of salts and other impurities. And that meant that it couldn't just be coming from the surface of the ocean. It had to be coming from deeper down. You see, when you have a bunch of salts dissolved in water, it lowers the freezing point. On Earth, this is why we can keep our pipes from freezing by turning the water in them into a salty slush. Because of all the salt, the freezing point of the ocean on Enceladus is around -40 degrees Celsius. But the temperature of the ocean isn't the same everywhere. It decreases as you go deeper because the pressure increases, and that means that the ocean gets colder the deeper you go. Scientists estimate that the bottom of the ocean is around -90 degrees Celsius. Now, even though that sounds incredibly cold, it's actually warm enough to keep the ocean liquid. And where is all that heat coming from? Well, that remains a mystery. One idea is that it's leftover heat from when Enceladus formed billions of years ago. But it probably wasn't hot enough to keep the ocean liquid this whole time. Another idea is that the heat might be coming from radioactive elements in the core of Enceladus. But that doesn't seem very likely because the ocean is way too salty to be explained by a radioactive core. Scientists also ruled out the possibility that Saturn itself was heating up the ocean. Basically, they did everything they could to find an answer, but they haven't been able to figure out what's keeping the ocean warm. In fact, it's so mysterious that scientists are starting to wonder if we're missing something. Maybe there's some kind of energy source that we don't know about. Or maybe there's a crack in the crust of Enceladus that allows heat from the interior of Saturn to leak in. Either way, there's clearly something going on here that we don't understand. And since we don't fully understand it, we're gonna continue to study it. Thanks for watching this episode, which was brought to you by our incredible community of patrons. If you would like to help us make more videos about the ocean on Enceladus and other cool stuff, you can go check out our support page.